Hi, I'm Hopeful and I'm going to present my PSM project, which is about the synthesis and structural characterizations of molybdenum chalcogenide thin films. Thanks to my supervisor, Prof. Dr. Joseph, and also the internal evaluator, Dr. Hambali and Encik Muhammad Faizaz. These presentations consist of four parts, which is introduction, literature reviews, methodology, and also preliminary results. Thin film is a layer of material with two-dimensional which deposited on the large substrate, and the thickness is around a fraction of a nanometers for a single layer to a micrometers for multi-layers. And we use the XRD, X-ray diffractions, and scanning electrons microscopic, or the energy dispersive X-ray spectroscopics, EDX, to investigate the thin films. We have three problem statements for this project. The first one is high demand of silicons for solar system applications. As we know, the silicons currently account for more than 90% of the solar cells markets. And the second one is high reflectivity of the silicon surface. Roughly 30% of the incident sunlight is reflected from the surface of the silicon cells. And the last one is less conversion efficiencies. The radiations must pass through the thick atmospheres that surround the Earth, and the different phenomena such as the scatterings and the refractions of the light will reduce its intensities. The ozone layers prevents the harmful ultraviolet radiations from reaching the Earth. We have three research objectives for these projects. The first one is to determine the suitable potentials to be used using the cyclic photometry analysis. Second one is to analyze the molybdenum chalcogenide thin films by using electron deposition method. The last one is to investigate the structural characterizations of molybdenum chalcogenide thin films by using X-ray diffractions and also scanning electron microscopy. The scope of the research is to design an experiment with focusing on the stoichiometry, structures, and characterization of the thin films. An electron deposition strategy will be used to synthesizing the molybdenum chalcogenide thin films. The range of the size for the thin film is obtained by the scanning electron microscopy (SEM) or energy dispersive X-ray spectroscopy (EDX), and also X-ray diffractions. Literature reviews. The transition methods. Currently, the orbiter consists of four orbiters, which including X, D, P, and F. And for the transition method, it only have the half full at the D orbiters. And according to the International Union of Pure and Applied Chemistry, the transition methods can develop a stable cations, and these methods can be able to discover in group 3 until 12. The molybdenum is one of the materials for the transition methods, as it fulfills the position requirements for the transition methods. And the electron configuration is 2s 18 13 1s, and it consists of 42 electrons and has 6 valence electrons at each outer cells. And this figure shows the periodic tables for the elements, and we can see that the yellow color represents the transition methods. The chalcogenides include sulfur, selenium, and tellurium. It covalently bonded to the group 14 and group 15 network forming to form a binary, tertiary, or quaternary glass systems. Each photosensitive effect can be used to add optical structures into the films. Transition metal chalcogenides has two forms, which is trichalcogenide and dichalcogenide. A band gap is energy which from the valence gap of the electrons to the conducting bands. A band gap for the dichalcogenide which exhibits from 1.0 to 2.1 electron volts, While for the Chalcogenide, it gives a band gap between 0.21 to 1.90 electron volts, and their band gap is not susceptible to the photolysis, which will give the optimum efficiency for the solar energies at the highest levels. X-ray diffraction is a strong and non-destruction method that determines the properties of crystalline materials. The atom distribution in the lattice displays the peak intensity and is fully distracted by the periodic arrangement of the atoms in a specific substances. According to the Branch law, the X-ray spectrum is distributed into the distinct wavelength as X-ray diffraction crystal. For the figures at the right side, the X-ray refracted from the surface of the substances travel a smaller distance than the X-ray refracted from the atomic surfaces inside the crystals. Penetrating X-ray travels down to the inner layers and refracts to travel the same distance before returning to the surface. And the distance traveled depends on the separations of the layers and the angle which the X-ray enters the materials. Hafizi 2022 used a path analytic accelerator detector and monochromatic radiation with 1.54 to investigate the phase structure of each interested materials. The probe molybdenum disulfide was shows the peak of the diffraction at 33.3 degrees, 41.1 degrees, and 58.31 degrees, which is assigned to the lattice planes 100, 103, and 110 respectively. And these three diffraction peaks will show the hexagonal planes of the thin films. The scanning electron microscopy is used a beam of focused electron to analyze the surface of the materials. It scans evenly over the materials to gather the details by stimulating the secondary electrons and backscatter electrons. And it consists of electron sources and two or more lenses, a diffraction system, a vacuum system, a control console, and an array of detectors for analyzing the resultant signals. And electron guns or electron sources generate the electrons and accelerate them to energize in the range of 0.1 to 30 kilovolts. Kowalik studies the surface morphology of the molybdenum cellular thin film by scanning electron microscopy, which is using SU-70 instrument high touching. It deposited at the potential negative 0.6 volts at the copper substrates. And it shows the homogeneous and compact lamina structure without any visible grain structure, and it completely covers the copper substrate without any fractures or pinholes. And one of the applications of thin film is electrical and optoelectronic applications. There are three types of the thin film cells which is often used in the solar cells market. First one is silicon-based thin film cells, chromium telluride thin film cells, and the last one is copper-induced gallium selenium thin film cells. And among of them, the copper-induced gallium selenide thin film cells will show the highest efficiency conversions as it can reach until 22.8%. Methodologies. And this figure shows the flowchart for the procedures. To synthesize the molybdenum chalcogenide thin films, an ammonia solution will be used to deposit the thin films. The thin films will be deposited for around 30 minutes and at 40 degrees Celsius. A Prince enters a bright research module VESA Step 3 constant potentials apparatus will be used to deposit it. A saturated cadmium electrons will be act as a reference electrons, and the graphite will be used for the counter electrons, and IT or coated glasses or stainless steel substrate will be the working electrons. The range for the potential limit for the cyclic potentiometry, which used in the deposition potential of the transition methods, is between -2 to +2 voltage. It is necessary to ensure that the positions of the working electrons and the counter electron are placed as close as possible and keep parallel to each other, as it will affect the performance of the released ions to be attracted successfully and deposit exactly perpendicular to the cathode surface. And we also need to calculate the film thickness. And for the density calculation, the relationship between the mass and volume is used to calculate the thin films. The following equations shows the relationship between the mass and volumes in the density calculations, where the density equal to the mass value versus the volume. For the structural study, we use the XRD, X-ray diffractions. The X-ray diffractograph will be produced to analyze the structural characterization for thin films. The Pan Analytic Expert Prof PW3040 versus 60 diffractor method with monochromatic radiation 1.54 in two angles range of 10 degrees to 90 degrees will be used for determining the lattice parameters. And for the morphology and the composition study will be through the SEM or EDX. A SM6400 JEOL scanning electron microscopy will be used to investigate the surface morphology of the thin films. A focus beam of the high-energy electron will be produced, different the signal on the surface of the intrasamples, and collect the data to generate the image for the surface of the samples. The EDX will be used to investigate the compositions of the thin film samples. Preliminary results. So based on the previous research, we found that the existing solar panel materials are expensive due to the wide uses in both electronic and semiconductor industry. The conventional efficiency of the present silicon-based materials are only about 12 to 13%. So we expect to synthesize the thin films by using an electron deposition process, and the thin films of the transition method Chalcogenide will be successfully deposited on the prepared substrates. Characterization of the thin films by X-ray diffraction will be revealed the crystallographic details. The scanning electron microscopy will be shows a smooth surface of the thin film with uniform pinhole-free natures. The synthesized films confirm the suitability for being the alternative materials in the solar panel applications. So that's all from me. Thank you.